A very good morning to all of you. We are the freeform. So we wanted to experiment in organic shapes. So we wanted to push Ecor to its limits and test its potential to form freeform shapes. This is all the testing that we've done. So to start off with, this is a one-off design, designed exclusively for CEMEC. We wanted to experiment with double curvature, and we wanted to manipulate the spatial experience of the place. So we wanted to bring the outside to the inside. We wanted to mimic the nature. We wanted to mimic a tree. So this tree comprises of three elements: the interior support structure, the panel that wraps around it, and then the molded leaf. So we used three different manufacturing techniques to construct this tree: interlocking, bending, and molding. So the construction principle was simple. We build the interior support structure with an interlocking system. We bend the panel around it, and then we sew it to the panel. So we began testing this in a smaller scale. We used cardboard. We interlocked planar surfaces and found that it was extremely rigid and strong. So for the next part, for the panel, we thought we would divide it in 700 millimeter intervals for the ease of bending it around. So we used cardboard for this as well. We soaked it in water and wrapped it around the waffle structure to get the freeform shape. But while doing this, in certain areas where there was a large surface area, we saw that the cardboard tended to ripple and deform. So to counter this, we designed perforations which were going to make the bending and the rippling, reduce the rippling. So after the cardboards were cast in place, we sew it to the interior support structure to hold it in place. So this was the process. So we wanted to scale it up and try it in a bigger model. So before we began, we started with the Ecor sheets. We submerged it in water for 5 minutes, and we tried to double curve the surface. We found that double curvature was possible to some extent. So we wanted to go further with the experiment. So we started building the interior support structure with MDF panels. We used an interlocking system for it. If we were to do this with Ecor, we would have used a honeycomb panel, which was actually more lightweight and more rigid. So after the interlocking system was done, we used hardboard in place of Ecor sheets. We submerged it in water and wrapped it around the waffle structure. We had to carefully do it slowly. And once it was set in place and cast into shape, we drilled holes into it and sewed it in place. So if we were to do it more efficiently by doing all these experiments, we thought we would laser cut it using the Ecor panels first, submerge it in water, and then put it onto the waffle structure. So this would be the most efficient way to do it. So this brings us to the next final component, the leaf. The leaf is merely an aesthetical addition to the tree, just to enhance the spatial experience. But the leaf shows the potential of the Ecor material to be molded into freeform shapes. So to do this, we started building a mold using cardboard and foam board, and we wrapped it around with a plastic foil. We made a mixture of gypsum and put it all over it, let it get into shape. And then we applied layers of newspaper strips. We made a paper mache model. So we used newspaper strips instead of the raw Ecor material, which we did not have access to. So we applied 12 layers of paper mache and then let it dry. So once it was dry, we bended it, made a slight incision within the strip, and then we interlocked the structure to form the final model. So we had the double curvature leaf. So if we were to do this with the Ecor pulp, we would have manufactured a metal mold. We would have put the Ecor pulp in it and then pressed it with a counter shape to form the form. We did our own mass production of the leaf to test the slotting. So we tried different types of slotting, and we found that number 7 was the strongest. And then we tried it on the leaf. We applied the same pressure for both the leaf, and we found that number 7 was actually pretty strong. So we made more of them, and then we put it onto a tree. This gives you an overview of what the tree looks like. So with these three manufacturing techniques, we achieved freeform and an organic shape with a double curvature. So this brings us back to where we began. We wanted to experiment with the material. We wanted to see if it had the potential to form an organic shape with a double curvature. And we wanted to experiment with the spatial experience. So we finally built something, the tree, which stands as a showcase to show the potential of Ecor. This shows what Ecor is capable of. This shows that Ecor can be molded into freeform and organic shapes. This could be the future of the semi. Thank you.